Hi everybody, welcome to a short video that's going to give you a little bit of background information into why I developed the My Putting Template, a little bit about the concept behind it and how it can help you or your students monitor and develop their own putting stroke. So the main reason I created the template was to give people a reference for which they could monitor, track and develop their own stroke, a way that they could calibrate themselves on a day-to-day basis. The great feature about the template is you can record from above your own stroke, so you can start to monitor the path of the stroke, your rotational pattern, where you're striking the ball, and of course your start line, which are really important facets in terms of developing the ability to start the ball on line consistently and hold puts. So that's the whole concept behind it. It wasn't about creating these references that people would try and perfect and match every single aspect of it. It was more about creating references for yourself, what are my tendencies and how do I manage them. So obviously I appreciate that people have different strokes, different arcs, different strengths of arc, different rotational patterns, etc. So I needed to create a template which had some a different range to accommodate different strokes. So I needed to start somewhere in terms of a concept. I needed a concept to be able to construct these multiple different templates. So I'm going to try and talk you through that concept to help you understand a little bit more about the My Putting Template. We've got the 18 arc, 18 pure arc on the floor. And I've got this full swing training device which allows me to stick a alignment stick at a particular angle. Now I've got this at 18 degrees which matches the template here, just to help us depict what a plane angle would look like. So one of the key things about the concept behind the template is we've taken different plane concepts. So we've taken the idea that the putter can work on a plane, and we then created various different planes. That was the first thing that we looked at to try and build this construct. So for example, if I had no inclined plane and had a vertical line here and the sweet spot worked up and down that line, you could see that there would be no curvature in that stroke, that the stroke would be straight back and straight through, which in reality doesn't happen or shouldn't happen. The putter will work on some element of an arc. So the more I create an inclined plane, you can see that if the sweet spot worked up that plane, it would create some curvature. Okay, so we go 12 degrees, 15 degrees, 18 degrees, 21 degrees. So you can see the different arcs that we have represent different inclined planes, which would create different amounts of curvature in how the sweet spot moves. Now, one of the other variables we had to compute was the radius of the stroke. The radius will have a big impact on that three-dimensional movement of the sweet spot. So, and I'll give you an example here. So if we have the club set up to match this 18-degree plane, and I work the club up along that plane, okay, we can see that there's a certain depth to that sweet spot and a certain height. If I was to work the club up that plane in the same planar manner, but my radius is a bit shorter, we can see that we'd have a lot more depth, okay, and height to that sweet spot. And the opposite, if I had a very long radius along the same plane, I've got a different height and depth to the sweet spot, and I'd also have a different amount of rotation. So the radius is key to along any plane to depicting how that three-dimensional curve, the three-dimensional movement of the sweet spot would look like. So we looked through our research at what typically a typical radius look like, and I had some help in the creation of this template by a very clever friend of mine called Dr. Roger Brooks, who's been involved in golf and golf product design historically. So along with Roger, we came up with a radius which really that we use and is the cornerstone of this construction. So with a known and fixed radius, and then his idea of different inclined planes, what we then did was to map out what that would look like on the ground. So the template is essentially a 2D representation of that 3-dimensional movement of the sweet spot. What would that look like on the ground? Now, the different templates really reflect the fact that people move the club differently. They'll have different curvatures. Some people will have very shallow arcs, some people will have stronger arcs. Now, whether that sweet spot moves perfectly along that 2D representation, I don't think is of massive concern. Certainly they were never created for people to match them perfectly. It was more of a case of creating a reference for where your stroke is on any given day. What I would consider to be more important would be where that face is relative to the overall shape of that template. You know, controlling your face angle is the primary factor we need to sort of, master in terms of controlling direction. So creating an understanding of how your rotation works along that curvature, along that template would be more important. So a great way to kind of understand that is to video from above to get a sense of how your club face works relative to the markings on the template. You know, in particular the face angle template's great to give you reference for how your club would be relative to the face lines. The face lines on each of these templates would represent what the club face is like square to that arc. So at what point does the club open or close excessively and then affect my start line? So it's a way that you can kind of self-coach, monitor your patterns over time, if they change and in what direction are they changing. So that's the idea of the templates. We've got obviously different inclined planes. They with a given radius that they'll create different projections. Now, I get asked this question a lot in terms of, I have a certain line angle of club, what template should I use? Well, line angle is really not necessarily a variable which will determine what template you should use. And I'll give you an example of that. So typically a lie angle would be in and around sort of 70, 72 degrees, somewhere around the 69, 72. Now this putter that I've got is a 72 degree lie angle. So in theory that matches perfectly this 18 degree inclined plane. As I sit that putter down in lie angle, it should be matched perfectly to this plane stick. So now, if I perfectly trace this template, it means that the club then is working perfectly up this plane line. And I've got a laser device here which is attached to the shaft, and these laser devices work through giving us feedback as to what that club head or the sweet spot and shaft are doing. So if I work up that plane line, then you can see the laser stays on the ball to target line, it doesn't twist. And that's because the sweet spot is working up that plane, that 18 degree plane, that shaft plane, and also the club face is staying square to that point. So I'm really working the sweet spot up the plane of the shaft. That sweet spot plane now matches my shaft plane. The rotation of the putter is square to that shaft plane. So the 18 degree would be a perfect template for someone with a 72 degree lie putter that was trying to work it on shaft plane. But the reality is, very few players work the club on shaft plane. It's merely a concept. And I'll give you a few insights to sort of debunk that concept at times. And here's a really good common example that I would see, but there's a player that I work with, Matt Fitzpatrick, who's a great putter. And he would have a fairly erect lie angle, so in and around about 73 degrees. And then how he would work the putter would be more around, so the shaft would actually work in a more cylindrical manner rather than a planar manner. So as a consequence, the sweet spot you could see there worked flatter than the 18 degree projection on the ground, even though his putter would be 73 and 17 degrees from vertical. So Matt doesn't work the shaft, the structure of the shaft, up a plane. Matt, and this is very common, he would work a shaft in a more cylindrical manner. So what you can see here is, this is my kid's wobble board, but you can see the shape, the cylindrical shape here. If I put that on a slight incline to match his 73-degree lie angle, you can see the shaft would work up, along and around, okay, this cylindrical shape. And that would give you more depth than in the sweet spot. And if the club face is staying square to that shape, you're going to get more rotation. The structure of the shaft isn't necessarily working up that plane, but we can create a plane shape from the travel of the sweet spot. And that would be a common pattern that I see with lots of good players, is the shaft doesn't work in a planar manner. The shaft doesn't always match the plane that the sweet spot is working on. So the templates are all based around what's the plane that your sweet spot is working on, and then what would the face angle look like to be square to that plane. And through the years, post creation of these templates, through further research, I think we could actually release some flatter sweet spot planes to give players maybe more accurate references to what they do. I see with a lot of good players that the sweet spot plane will often be flatter than shaft plane, and they don't work the shaft in that planar manner. You know, I'll give you another example. You can have someone who's got a very flat shaft and then has a very shallow sweet spot plane. So that shaft in itself would be working in a cylindrical manner the other way. And final example to debunk that myth about shaft angle is, if you took a robot where you had 1 degree of rotation, so we had like a pivot here that we tilted ever so slightly, and then created 1 degree of rotation, so everything was coming from this single pivot point. If I had a very flat lie angle and, you know, rotated around a single pivot point, we would create a very shallow arc. Okay, now if I had a very upright lie angle and then we rotated around the single pivot point, we would create a stronger arc. Okay, so geometry wise, the lie angle doesn't influence the stroke shape in the manner that many people would think. It's actually the opposite. But the problem there is that, you know, often when you change lie angle, people can react to the lie angle. So it's more about how the player moves. It's more about all the multiple degrees of freedom that we have and how we generate movement that's really going to impact the stroke shape that we have, the curvature, the template that we need. And you know, it's in essence then very much at times a trial and error process to decide what's the correct concept for me to work towards, what's the correct template that I should use. I think, you know, I always encourage coaches to use these templates to help fit a player, because I do believe there's an element of trial and error in that fitting process. But if you don't have the opportunity to take a lesson, I would then look at what's your concept, what's the issue that you have. If you're someone that takes the club outside, okay, and you're trying, and as a consequence can hit pulls, then you're trying to create a little bit more arc. You know, you're not going to go to a 21 arc. That's very, you know, got a lot more shape than what you're used to. So you may start at 12 and a 15 and then see how that pans out. If you're someone that gets too deep in the backswing or over rotates the club in the backswing, you're probably going to go to the shallow end of these arcs. But it's more of a case of monitoring your stroke. So if you're hitting a few putts on that template, stroke feels good, your start line's good, then film that from above. Monitor what point the club face is square to the lines. Monitor the travel of the sweet spot, you know, the point of contact, and create a reference for your stroke that you can record and always go back to if you're struggling. And I think that's really important, is creating a library of your own stroke. Just to kind of conclude really then, that the templates created by creating this concept of different planes with a known and fixed radius. We could work the club on different radiuses, and that would give us a very different look along the ground. So your club could be working on an 18-degree plane, but if you've got a longer radius, you may suit a 12 or a 15-degree arc. So you can see there are a lot of variables that go into determining what template shape you should use, and really that's one of the reasons why we've never been able to create a very simple and systematic way to fit people, as it's very dynamic and it changes very easily, so we've always avoided doing that. So we've got the planar system, fixed radius, creates different shapes, and then ultimately it's a case of using that template to record your stroke, work out your patterns, pay attention to the rotation relative to those arcs, relative to the face angles, at what points it get too much, too little, and then match that to how that affects your starting line. That would be the key way to use a template. And I think one of the great things that we can do now with phones, tripods, is to film the template from above so that you can see your stroke pattern, see the general direction of your stroke. Are you imparting some side spin, or does that create poor contact as a consequence? And as I mentioned just previously, what's the rotational pattern and how does that function? Thanks for taking the time to listen to the video. There's some not easy terms discussed in there, but hopefully you can understand the premise of what we're trying to do and how we're trying to help golfers. If you have any questions, you can obviously, if you follow us on Instagram or Twitter, feel free to contact us. In the meantime, stay safe, and I hope you're practicing with purpose.